The topic is sized integer types. And to become a better programmer, I create a code that is compiled all the platforms without an error. So in previous lectures, we were studying data types. We studied character. We studied short, which was 16-bit. Character was 8-bit. And then we studied int, which was 32-bit, and long, which was 64-bit, and etc. How do we know that the long number is exactly the same, or long is exactly the same across compiler? We'll have to check, of course. And to get to this problem, if you're writing an algorithm which is really so much specific to sizes and ranges, then better would be to use the types that usually are defined by the compiler, the base types. And those types have been incorporated. TCC compiler that we are using at the moment, directly in stdint, they are included if you compile writing int, and we say what. So this is our variable. This is the type. So this is just going to compile just fine. But if you're using GCC, you send your code to somebody who is compiling your source code with GCC, then you need to include stdint. So I would recommend, even if you're writing the source code using TCC, compiling using TCC, yet you include this header so that these types are available, even if the code is compiled with GCC. So this is 16-bit, this is 8-bit. It ensures that this is 8-bit. This is just one character. And then we have 16, int 16 underscore t, which means it's 16-bit, as the name tells you. It's just a word, 16-bit. And this one is 8-bit. Same way you have 32 integer. For example, just add underscore to int, and this is going to be just fine because we have added underscore and it became a variable. If you remove this, this is going to be a type, and you. And then this is 32-bit. And then, most importantly, if you are worried about different compilers, or maybe you get to 32-bit compilers, or even some outdated compiler, or a newest one, and you do not know what is the size of the common types that we have studied previously, then you use these sized integer. We also have int 64. And let's call it underscore 64. That's it. Underscore 64i. Because it's starting with an underscore, so it's a valid variable. And this is 64. So I hope you did understand what I mean. To use sized integer and to be really so sure about the sizes of these integers in memory and the ranges, you are going to use exactly the same way. And secondly, if you need to use unsigned, you do not need to specify unsigned here. It's not really necessary. Just use u here along with all of this, and that's it, you are done. So it's unsigned integer 64-bit type. And here we have the. Now there's one more catch. When you are assigning larger values to variables, for example, we assign a value to int, and we say int is variable. I think let's make it 32i. So that's expressive, 32i, and we are assigning a value to it, some larger value. We do not know either it's in range or not. And we want this value to be unsigned while being assigned. So you use u for unsigned, and you can use for unsigned long, you can use UL unsigned. So this becomes a new constant, which is valid constant. Once we study other data types, other kind of constants, how to define an octal, a binary, a hexadecimal value, etc., that would probably be getting something here as well as a prefix. So the purpose of this lecture was to let you know the sized integer types. These are the basic types one can use in the compiler, in the C code, and make sure that their data types are good enough to hold the values and ranges throughout the application and cross-compile on all the valid C compilers. Microsoft C compiler does also have __int, etc. And I'll be showing an example on the right side. You can check that in the notes and memorize these things. In the future, we might be using exactly the same data types instead of the commonly used data types that we have studied previously. Thank you very much.